Alrighty everybody, here are the notes for lesson 4.1, one-to-one functions and inverse functions. So in a one-to-one function, each x value corresponds to only one y value, and each y value corresponds to only one x value. So a function is one-to-one if for all elements a and b in the domain, a is not equal to b implies f of a not equal to f of a. That is, different values of the domain correspond to different values of the range. So nothing repeats. Okay, so deciding whether functions are one-to-one. So if we graph this first one, it's the same as y equals mx plus b. So lines are one-to-one. The second one, 49 minus x squared, it's not one-to-one because since we're squaring the x, a negative number like -4 squared equals 16. There's two equal signs. Or a +4 squared equals 16. So both of those would give us the same value. So not one-to-one. So remember how we had the vertical line test? So if a graph passes the horizontal line test, a function is one-to-one if every horizontal line intersects the graph of the function at most once. Okay, so using the horizontal line test. So this is a cubic function. So it's an odd function. And it passes the vertical line test, so it's one-to-one. This is a quadratic. So it's an even function. So it's not one-to-one. In general, a function that is either increasing or decreasing on its entire domain, so these are all odd functions, must be one-to-one. So test to determine whether a function is one-to-one. So f of a equals f of b implies a equals b. That means that f is one-to-one. In a one-to-one function, every y value corresponds to no more than one x value. To show that a function is not one-to-one, find at least two x values that produce the same y value. Sketch the graph and use the horizontal line test. If the function either increases or decreases on its entire domain, then it is one-to-one. Okay, deciding if functions are inverses. So inverse functions, they have to be one-to-one, and then you do f of g of x and it has to equal x, and g of f of x has to equal x. The condition that f is one-to-one in the definition of inverse functions is essential, otherwise g will not define an inverse. So on this first one, we're going to do f of g of x. So remember, that means the second one goes in the first one. So 2 times 1/2 x minus 5 plus 5. So I get x minus 10 plus 5 gives me x minus 5. That doesn't equal x, so this is going to be a no. So if I did g of f of x, I get 1/2 times 2x plus 5 minus 5. So I get x plus 5/2 minus 5. So it's still no. So let me show you one that would work. So if I had f of x equals x cubed minus 1 and g of x equals the cubed root of x plus 1. So if I did f of g of x, so I get the cubed root of x plus 1 cubed minus 1. So I get x plus 1 minus 1, so that's just x. And if I do g of f of x, it's the cubed root of x cubed minus 1 plus 1, which is the cubed root of x cubed, which equals x. So these two would be inverses because they both equal x. So by definition of inverse function, the domain of f is the range of the inverse. That little -1 denotes inverse. And the range of f is the domain of the inverse. Okay, so determining if functions are one-to-one by looking at the points. First you look to see if it's a function, so none of the x's can repeat. So it is a function. Now you have to look and see if it's one-to-one. Do any of the y values repeat? No, so yes, 1-to-1. So on g, so yes, it's a function because none of the x's repeat. It's not 1-to-1 because that repeats. So this table is a function. And it is 1-to-1. Okay, so equations of inverse. The inverse of a 1-to-1 function is found by switching the x and y values and then solving for y. Okay, so there are the steps for finding the equation of an inverse. So for the first one, remember this parent function looks like this. So not 1-to-1, so no inverse. Okay, the second one is a line, so it is 1-to-1. So I would do y equals 4x minus 7, switch the x and the y, and then solve for the y. So x plus 7 divided by 4 equals y, which equals the inverse. And then the same thing on c. Y equals x cubed plus 5. X equals y cubed plus 5. X minus 5 equals y cubed. Cubed root both sides. So the cubed root of x minus 5 equals y, which is the inverse. Okay, so this rational function, it says the following rational function is 1-to-1. Find its inverse. And x cannot equal 5 because that would make the denominator 0. So first I'm going to do y equals negative 3x plus 1 divided by x minus 5. Then I'm going to switch the x and the y, and then I'm going to solve for y. So first I have to get rid of the denominator. So then I have xy minus 5x equals negative 3y plus 1. So I have to get the y's on the same side. Xy plus 3y equals 5x plus 1. Factor out the y's. Divide both sides. So this would be the equation of the inverse, and x cannot equal 3. X cannot equal negative 3. So lastly, by looking at graphs, to be an inverse, it has to be a reflection over this y equals x, and these are not reflections. So not a reflection, not 1 to 1. Okay, that is all of 4.1.